others. The reason we learn different methods is because you're more likely to get it right if you use the appropriate method. Best for the problem. So let's look up here. What do you notice is peculiar about this problem? It's missing the Vmax value. So we solved that one by isolating x squared, right? So our first step will be to add 7 to both sides. So that leaves me with 2x squared is equal to 200. Now x squared is not isolated yet. What will we do next? Good, you have to isolate x squared completely. So we would divide by 2. So we have x squared is equal to 100. Now x squared is isolated. Let's square root both sides of the equation. So our root cancels out like power. We get x is equal to
Plus and minus 10.
Good, plus and minus 10. If you forgot the plus and minus, you made it wrong. Questions? 2 answers. How many forgot plus and minus? Oh, dang it. You won't tomorrow then, hopefully. Okay. All right, so there should be 2 answers. We have to have plus and minus. Questions on that? Okay, let's do this one. First of all, are we missing dx?
No.
So we can't use that same method. So the next thing we do is always make sure our quadratic is set equal to 0. So I'm going to bring -3 over, but how do you bring it over? Float it? Good, we have to add 3. We have to algebraically bring it over. So we have x squared minus 4x plus 3. How many were able to at least get that far? Okay, good. Then from there, you could have solved using the quadratic formula. However, I do not choose to ever use the quadratic formula unless I have to. Because look at it. Is it quick factoring? Yeah, if it factors, isn't it going to be quick factoring? So let's try that. So with factoring, we would be saying what multiplies to be a times c, so what multiplies to be positive 3 and adds up to be b, -4. What are the factors of 3? 1 times 3. Now it needs to add up to be -4, so they both have to be negative. Is -1 times -3 positive 3? And then -1 plus -3 is -4. So our factors are -1, -3. Because my a value is 1, I can factor this quickly. So I put an x and an x, then I insert those in. So that's a -1 and a -3. Now am I done? No, that is literally that. It's just this is in a prettier form for us to solve, right? So we're not done. But what can we do? If we distribute, we'll end up back here. What will we do? Set it equal to 0. What's the rule that allows us to split it up?
0.
Good job. The zero product property rule allows us to split it up. So we have x minus 1 is equal to 0 and x minus 3 is equal to 0. Then solving for x in each case. Add 1. So I get x is equal to 1. Add 3. X is equal to 3. How many of you got 100% right? Okay, good. I hope to see more hands in the next few days. Because, guys, you've got to be able to solve quadratics of all kinds. Okay, any questions on that? Are you sure? Okay. So solving by factoring is pretty quick. Here we go. All right, so now just to review on what we did yesterday, really quick. You don't even have to start taking notes. Just look. We know the square root of -1 is equal to I. Thus, I squared is equal to -1. That was the big thing we used yesterday. I squared is equal to -1. So we rewrote the square root of -9. We know it's not -3. That's incorrect. We know that's the same thing as 9 times -1, right? What's the square root of 9?
3.
What's the square root of -1? I. Very good. And then this one, we know that's the same thing as 8 times -1. What's the square root of 8? Oh, it's a decimal. So we say, I know how to break that down by hand. If it does. 4 times 2, 4 breaks down into 2 times 2. We're pulling out groups of 2. There's 2 of them that can leave. So there's 2 2s. They can leave. No other 2s to pull out with that. And then can't the -1 always leave?
Yeah.
It's always an I, right? So we have a 2 and an I on the outside, and left was a square root of 2. And then this one, 7 times I squared. What is I squared? -1. So isn't that the same thing as 7 times -1? Which is -7. Questions? So I'm going to throw, for you advanced learners out there, a problem on the board. Let's find I to the 9th power. Let's find I to the 9th power. If you see this on an ACT, especially you advanced learners, you should not miss it. What's I to the 9th power? So let's go like this. Can't we rewrite it in terms of 2? Yeah? So we have I squared times I squared times I squared. That's 246 times I squared. 2, 4, 6, 8. And we have 9 of them, right? So we put another I to the first, right? Now we know that I squared is negative 1. I squared is negative 1 times negative 1 times negative 1 times I to the first. So type it in your calculator. Negative 1 times negative 1 times negative 1 times negative 1. What do you get?
1.
Is it positive or negative?
Positive. Wait, what is I? Well, to the first.
I to the first is just I.
Like, is that negative 1 or 1?
Neither. I is I. Okay, so you got what? Positive 1, I. Sweet. What's 1 times I? I. Very good. So don't miss out on your ACT test, okay, guys? Okay, awesome.
That's so, why would they do I don't if it's just equal to I?
Because they want to know if you know what I squared is equal to. It could have come out, depending on what this is. What if it was I to the 10th? It wouldn't have been I. It would have been 1, right? Does that make sense? It would have been negative 1. So you would have had another I squared, right?
Okay,
And then we would have, do you get what I'm saying? So there's many different answers. I mean, it's going to be between I, negative I, 1, negative 1, right? Do you get what I'm saying? Okay, sweet. Moving on. So yesterday we learned this as well. So I just want to review with you. This is just a complex number, subtract a complex number, but it's just a fancy complex number. Negative 3 minus, what's the square root of negative 4?
2.
Not negative 2. What is it?
2. I.
Nope, 2i. Very good. Subtract, we have a 5 plus, what's the square root of negative 5? 5i. And then, do not multiply. Incorrect. It's subtraction. So I like to say, okay, negative 1, that's really negative 5, and that's really negative 5i, right? Now don't double dip. That negative is gone. We just erased this whole thing. You understand that? Now you just combine my terms. Negative 3 plus negative 5.
Negative.
And then negative 2i plus negative 5i.
Negative 7.
Negative 7i. Questions on that from yesterday? One more from yesterday, then we'll get to today. Multiplication. So once again, this is a fancy complex number times by a fancy complex number. So we have 2 minus, what's the square root of negative 9? And we have negative 3 minus, what's the square root of negative 49? 7i. Then we'll distribute. Carefully, this one's really tricky and there's a lot of room for error. 2 times negative 3. 2 times negative 7i.
Negative 49.
Negative 49. Questions? Now, a lot of you kind of get lazy and you don't draw in your rainbows and then you miss things. So just do it. Negative 3i times negative 3. Positive 9i's. Now, a lot of you were making multiplication errors yesterday with negatives. Negative 3i times negative 7i.
21 squared.
Good. Positive. A negative times a negative is a positive. 3 times 7 is 21. But I times I is I squared. Very good. Then we know that I squared is equal to negative 1. So we really have 21, positive 21 times negative 1, right?
Yeah.
21 times negative 21 times negative 1. Negative 21. So then I'm going to say I just simplified that. So now combining my terms. Negative 6 plus negative 21. Negative 27. Negative 14i plus 9i. Negative 5i. Very good. Questions on that from yesterday? Okay, awesome. I just wanted to review. Okay, let's get to what we're doing today. So 6-9, we're going to be comparing linear, quadratic, and exponential models. So, back in secondary math 1, you focused on linear equations and exponential equations. So you should be experts in linear and exponential. Now in secondary 2, you take a focus in quadratics. So today we're going to be comparing the three. So now everybody look up here. A couple things to remember. Linear means degree 1, right? Lines look like this. Straight lines, right? This is a positive line and a negative line. Does everybody agree? Quadratics, we learned this year, are degree 2. We know they're nice smiley faces, nice frowny faces, they're nice U shapes. Questions on that? And then exponential. So you guys should have become experts in exponential stuff in secondary 1. So exponentials have the form a times b raised to the x. Fun thing to notice about an exponential. The x is in the exponent. Do you see how here our x is not our exponent? Here our x is not our exponent. But look, in an exponential function, the x is the exponent. Does everybody see that? Okay. So what happens with exponential functions are called is that they get exponentially larger or exponentially smaller. So everybody look at this picture of this graph. Do you see how it starts really, really small and then it's getting larger and larger and larger exponentially? Does everybody see it? And then this is starting really, really small, but it's getting exponentially smaller. Do you all see it? Okay. So you have to know what the pictures of the graphs look like. Okay, let's just get right to it then. It says, graph each set of points. Which model is appropriate for each? Is it quadratic, is it linear, or exponential? So the first way to be able to tell is to graph it. Look at the graph and then tell me what it looks like. So let's graph number 2 together. You all have graphing paper on your desk. So we're going to start with number 2. We're going to just plot the points and then we're going to look and say, what does that graph look like? So I'm going -2 up 0.75. So on the x-axis, I'm going -2 and up 0.75. So not up quite 1. 0.75 means a little bit less than 1, right? I graphed that one. Now I'm going to graph this point. -1 up 1.5. So -1 up 1.5. So I'm going -1 up 1.5. Now I'm going to plot this point. Over 0, up 3. Over 0, up 3. Now I'm going to plot this point. Over 1, up 6. Over 1, up 6. So then I'm going to go ahead and draw in my graph here. All right, is that a straight line? No, so we know it's not linear. Is it a U shape?
No.
No, so it's not quadratic. Is it starting really small and getting exponentially larger? Yes, so we say it's exponential. Questions on that one? One more from your worksheet, then I'll just let you go for a second. Number 3. So we're going to plot the points. So just go ahead and start plotting. -2 of 1, but you got to be able to plot them correctly. Over -1 up 0, so -1 up 0. Over 0 up 1. So over 0 up 1. Over 1 up 4. And over 2 up 9. So I have my points. I can go ahead and draw in my graph. So we know it's coming down and curving around, so it's probably coming up this way, right? So is that a line? No. Is it a U shape? Yeah, so we know it's quadratic. So this is quadratic because it has a nice U shape. So if it's a straight line, it'll just be exactly a straight line. Your slope will be the same every time. Question on how to do this. Pretty straightforward, right? Okay, so now I want you to do problems 1 through 8. Determine if it's linear, if it's a line, quadratic if it's a parabola, and exponential if it's getting exponentially larger or smaller. Go. So once again, that's just one way to be able to determine if it's linear, quadratic, or exponential, is graphing it and then looking and determining what does my graph look like. Never a bad method. But we're also going to learn another method, and it's algebraically figuring it out, because sometimes your graph might not be clear. Now, here's the steps I kind of take, and how you can know if it's linear, quadratic, or exponential. So the first thing to know is if it's linear or quadratic. So what you're going to be given is a bunch of xy points, and it might be given in its polar as points, and you're going to focus on the y values. So you're going to look at your y values, and you're going to take the differences of your y values. So you're going to subtract your y values. And if you take your y values and subtract them, and they're the same number every time after you've taken differences once, it's linear. Well, let's say you take the differences, you subtract your y values, and they're not the same. Then you're going to take those new values and subtract them again. So subtract them again. And if you subtract them a second time, and then they come out to be the same number, then it's quadratic, because you took differences twice to get the same number. That might not make a whole lot of sense right now, it will in a second. So let's say you take differences first and second, and it's not linear and it's not quadratic, because it doesn't come out to be the same in either case. Then you say, well, maybe it's exponential. So you can take your y values, but this time instead of subtracting them, you're going to be dividing them. You're going to be finding the ratios of your y values. If you divide your y values and it comes out to be the same answer, then it's exponential. And we only divide them once. Okay, so right now that might not make sense, but hopefully once we start practicing it will. Now here's the thing. I always check to see if it's exponential first, because I don't want to have to go through and find both of these if it's exponential. So that's what I'm going to do. So everybody, here we go. First example. So problem number 9, it says, which type of function models the data in each table, and it says use differences or ratios, and then write the equation. So, looking at this, we have xy points. Does everybody see how we have xy points? It's just in a table.
Yeah.
Now what we're going to be focusing is on only our y values. So we're going to take our y values and this time I'm just going to start with subtraction. So I'm always going to subtract my y values. So now here's the catch though. You have to listen to this. You have to subtract the y value that comes before the one above it. So we're going to start with negative 11. We're going to subtract this one from the one above it. So we're going to take negative 11, subtract this. So you always have to take the value that comes before the value above it and subtract it. Now this is where a lot of students make a lot of errors when typing it into their calculator, because this is what they want to do. They'll go negative 11 minus 12. That's not true. If this value subtract this value. So let's all practice typing it in. It's negative 11 minus negative 12. What do you get? 1. Now you've got to draw them in. Now you're going to take your y values and subtract them. You always start with the value that comes before the value above it. So type it in. Negative 8 minus negative 11. Negative 8 minus negative 11. 3. And we're going to do it again. Not missing anything in here. Negative 3 minus negative 8. 5. 4 minus negative 3. 7. Okay, when we took differences the first time, did we get the same value?
No.
No, so it's not linear. Let's move on and see if it's quadratic. So we're going to take differences of these values. Now remember, you've always got to start with the y value that comes before the one above it. So we're going to do 3 minus 1. 2. Okay, 5 minus 3. 2. Okay, 7 minus 5. 2. Okay, so we took differences once, twice, right, everybody? So since we took differences twice, it's quadratic. And it came out the same. If it didn't come out the same, we'd say it's not linear, it's not quadratic. Does everybody get what I'm saying? So it came out to be the same, so we know it's quadratic. But now we want to know, okay, yeah, it's quadratic, but write the equation. So we're going to just use our calculator. So everybody, turn on your calculator. Here we go. So you pull up your calculator. Remember that you go to Stat, everybody, and then into Edit. We've already learned this the first part of this unit, if you remember. So Stat, then into Edit is where it will put you. Hit Enter. Now make sure you have list 1, list 2. We've got to put it into list 1, list 2. If you don't have a list 1 or list 2 because you've deleted it, you'll reset your calculator. All right, so in list 1, I'm going to type in my x values. My x values were 0. You have to hit 0, enter. 1, enter. And you can just type over your values, or if you need to delete them, you can hit delete. But you have to hit the delete key up here, not clear, remember. So put in your x values. Then go over to list 2. Type in your y values. You've got to use the negative key if it's negative, not subtraction. And you've got to make sure they line up to be correct xy points. So type those in. Now make sure you don't have anything extra typed in or it's wrong. It's going to be wrong. So everybody, do you have list 2 typed in? So now you hit the stat key again. Head over to calculate. Now because we know it's quadratic, we're going to go down to quadratic regression line, which is right there, number 5. Quadratic regression line. Hit enter. Enter through that. And we get our quadratic regression line. So look right here, it says, okay, quadratics have this form. Our a value is 1, our b value is 0, our c value is negative 12. So this is going to be y equals, since a was 1, I'm just going to write x squared, because that is 1x squared, right? Plus 0x, I'm not going to write that, because plus 0x is gone. And then our c value is negative 12, so it'll be minus 12. So our answer is quadratic, and this is the quadratic that matches these points. Do you understand how to do it using your calculator?
No,
What's the problem?
I didn't get the same answer.
Then you didn't type in your x, y points right.
I did.
Did you hit quadratic or regression line? Check them again.
Number
Everybody
5.
always says that.
Number 5.
Yeah.
Okay. Yeah, we lead you 3, -2, -7, -12, 17. 3, -2, -7, -12, 17.
Yeah, I got the second.
You typed in number 10. This is number 9.
Oh, we're in number 9?
What did I do wrong?
Okay, let's do number 10 now.
Number 10.
So the first thing you have to ask yourself, is it linear, quadratic, or exponential? So let's see if it's linear.
Yeah, this.
So we're going to go ahead and take differences of our y values. So I'm going to draw this in, but not careful to miss any markers. So carefully here. What's -2 minus 3? -5. What's -7 minus -2?
0.
-5.
Right there.
What's -12 minus -7?
-5.
And then 17, no, this is actually a -17. Sorry, that was a typo. So on your table, this should have been a negative. My bad. So now we're doing -17 minus -12, and we get -5, right? Now look, we took differences once, it came out to be the same. Therefore, we know it's linear. So you're going to do the same thing. Go to your calculator, everybody, type it in. It takes me forever to do it on this huge screen, so I need you to do it. So stat, into edit. Type in your x values into list 1, your y values into list 2. So, well, I should be able to do it. Okay, and make sure you do -17.
Okay, done.
Okay, now we know it's linear, it's not quadratic, so we're going to make sure to choose the correct thing. So we hit stat again, over to calculate, and we're not going to go to quadratic. It wasn't quadratic, it was linear, right? So look, number 4 and number 8, we'll say linear. Either one will work. So I'm just going to use this one. Linear regression line. I hit enter, enter through, and I get y is equal to ax plus b. So y is equal to -5x plus 3. Which makes sense. That is a line. Y equals -5x plus 3. Does everybody see how to do that one? Okay, last one that I'm going to let you work the rest of the time, won't bother you ever again. Number 11. So it says, we have these xy points. It says, which type of function models the data in each table? So first of all, we could say it takes differences, subtraction. So 12 minus 3
Is 6.
12 minus 3 is not 6, but you know, nice try. 9. 48 minus 12, right?
36.
36. So we definitely know it's not linear, right? Already, right? But let's keep going. 192 minus 48 is 144. Okay, and then 768 minus 192 is 576. Okay, it's not linear. Let's see if it's quadratic. So we have 36 minus 9. 144 minus 36. 108. Okay, so we know it's not quadratic, right? Okay, so I'm going to erase that. Go back to here. We know it's not linear, it's not quadratic.
So you have to divide.
So now we're going to divide, but the catch is you still have to take the y value that comes before the y value above it. What's 12 divided by 3?
4.
What's 48 divided by 12?
4.
What's 192 divided by 48? And 4. So keep in mind, it was division. So we got the same thing when we divided. Therefore, it's exponential. So let's type it into our calculator again. So do it for me. Go. List 1, list 2. Type it in.
3 and 4.
Okay, so now this time you're going to go stat over to calculate and down to exponential regression line. So it's kind of far down there.
10. It's like 0.
It's, yeah, it depends. Everybody's calculator is a little different. So exponential regression line. I hit enter, 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 enter. Okay, let's see. What is it? Okay, so we get y is equal to a, which is 3 times 4 raised to the x power. Make sure you don't write it as a line. It's not a line, so you got to write them right. So we have y is equal to 3 times, I'm going to put that in parentheses, 4 raised to the x. So the x better be in your exponent or you've got it wrong. That's what makes it exponential. Does everybody see how to do these? They're not hard, but yeah, you got to be careful. Okay, here you go. Do problems 12 through 19 and 26. Read the directions. If it doesn't say what's the actual quadratic line, or like what's the actual equation, you don't have to. But on 14 through 19 and 26, you do have to find the line like I just showed you. The rest of the time is yours. You have 40 minutes roughly. Well, that's an exaggeration. 30 minutes.
35.
35.